Okay, Okay, now let us try these questions from line part. Okay, so find an equation for the line of intersection of two planes. Okay, so we have two planes. Find an equation for the line of intersection, meaning that this plane is intersect with each other. So this will be our pi1 and this will be our pi2. So pi1 is given as 5x plus y plus z equals to 4. And the second plane is 10x plus y minus z equals to 6. So in order to find the equation of the line, you must have you must have a point on the line and also a vector. So from here we have equation of plane, where this equation of plane we can obtain the normal vector for plane 1, where the normal vector is orthogonal to the plane. So n1 here can be obtained from this equation, where this will be our n1, which is 5, 1 and 1. Okay, then for n2 is the same, the normal vector of 2, where the penny vector will be 10, 1 and negative 1. So this will be 10, 1, negative 1. So now we have two vectors where you can get the other vector by using the cross product. So if you use the right hand, you will notice that this will be your this is your finger and this is your thumb. Okay, so this will be your n1, n2, and the vector will be here. The other vector will be this one, where the cross product of n2 and n1 is parallel to the line of intersection between these two planes. Okay, now we can get our vector that is parallel to the line of intersection. So we can have n1 cross n2 equals to I, j, k. And then we have 5, 1 and 1. So using the cross product, first we compute I. So 1, negative 1, 1, 1. So find the determinant and then minus. Don't forget a sign, it must be negative or j. So this will be 10, negative 1, 5 and 1, j. And the last one is for k, it will be 10, 1, 5 and 1. Then just compute this. So we have negative 2, 1 plus Okay. So this will be 2i and then minus 10 plus 5 is minus 15j, and then plus 10 minus 5 is plus 5k. So now we have the vector here. So we denote this as v, let's say v. Okay, now we have obtained the vector. And the last one is we need to find one point of intersection. So for the point of intersection, so to find the point of intersection between in this line, okay, we can just use these two formula. Okay. So here we have 5x plus y plus z equals to 4. And then the second plane, the equation of the second plane is this. So from these two equations, to obtain the point of intersection, you can just try adding these two equations. So what is left is that 15x plus 2y equals to 10. Okay, and then let us assume x equals to 0. So we substitute into equation 3 and we will have our y, where y will be equals to 5. Now we have the point of intersection where the point is equals to x is 0, y is 5, and our z. So now we just substitute our value of 0, 5 into the equation of 1 or 2. So 5 times 0 plus y, which is 5, plus z equals to 4. So z is equals to minus 1. Now we have the point and we have vector. So we can get the equation of the line of the intersection line. So you can write either in symmetric form or parametric form. It doesn't matter because the question does not didn't state to use the symmetric or parametric. Okay, so then we can use x equals to x naught, which is 0, plus 80. So our a is 2t. So this will be our a, b, and c. And this will be our x naught, y naught, and z naught. So y will be equals to 5 minus 15t, and z is equals to -1 plus 5t. Yes, you can also assume z equals to 0. Okay, because there are lots of points that lies on the line here. Okay, for me, I just for this calculation, I assume x equals to 0. You can also assume y equals to 0 or z equals to 0. Okay. Any questions for this one? Fakri, you get? Can you understand now? All right. Then another question. This last question. Okay, last question from the last part. Okay, find the if I use x equals to 2 or cannot. Yes, you can use x equals to 2 or any constant. It's just that if it's easier if you use x equals to 0. Okay, let us try the final questions from the last topic. Find the intersection of the plane 3y plus z equals to 0. And the sphere is given as this equation. Okay, so now we want to find the intersection of the plane. So from here, we have two equations. X squared plus y squared plus z squared equals to 4. So we can find the intersection of this from this equation. Okay, let us reorganize this equation 1, where our equation 1 will be z equals to minus 3y. Okay, so from here, we can substitute this equation 3 into equation 2. So we have x squared plus y squared plus z, where z is equals to minus 3y squared equals to 4. So this will be 10y squared, which is equals to 4. So now we want to find the value of x, y, z so that we can get the intersection of the plane. So let us assume x equals to 0. So this is our equation 4. So if we let x equals to 0, so we have here will be y squared equals to 4 over 10. Or y will be the square root of 4 over 10, which is equals to plus minus 2 over 5. So we have x, y. Okay, then we want to find the value of z, so we just substitute our value of y into z. So here we have z is equals to negative 3. So first we try to solve the positive, which is 2 over and 2 over 5. This will be 2 over square root of 10. So it can be negative 6 over square root of 10, or it can be negative 3 times with negative 2 over square root of 10. So we have 6 over 10. So now we have the value of point of intersection. Where the first one will be 0, and then our y is, for positive, it will be 2 over square root 10, and for positive, our z value will be negative 6 over root 10. Or it can be 0, for y is negative 2 over root 10, our z will be 6 over root 10. So you can give any value of the point of intersection as long as it satisfies the equation of these two planes. Okay, if you let x equals to 2, then you may get another value of y and also z. But as long as it satisfies these two equations, then it's correct. Okay, Khalid, can I use circle bracket for point and vector? For point, you must use this bracket, but for vector, you must use this square bracket. This is for vector, and this is for point. So that's why for point, I use this point, this bracket. Alright, so any other questions? Reason why is square root 2 over 5. Y is equals to 2 over 5. Sure. Y is equals to square root 4 over 10. Or it can be square root 2 over 5. Yes, it also can be 2 over 5. Or it can be square root of 4 over square root of 10, which is equals to 2 over square root of 10. Or if we simplify this, you will get 2 over square root of 2 times 5, which will be 2 over square root 2 times with square root of 5. So this will be square root of 2 divided by square root of 5. So it's just the same answer. Alright. So any more other questions? Tak ada. You can message me privately. I will read your chat. Ada lagi ke? No more questions? Number 5, planes. 5 planes. Alright, find the equation of the plane that is orthogonal to the plane 3x plus 2y. Okay, find the equation of the plane that is orthogonal. So you want to find the plane that is orthogonal to plane 3x plus 2y minus z equals to 4. And then we want to find the equation of the plane which is orthogonal to this plane. So what we want to find is a plane, this plane pi 2, where this pi 2 orthogonal to plane 3x plus 2y and goes through the points P negative 1, 2, 4 and Q negative 1, 3, 2. So it means that this so something like this, and there are points P and Q. So maybe the truth point P, let's say P and Q is somewhere here. Good. Okay, or it can be somewhere here. Alright, so now we have two vectors. The first one is our vectors. The plane goes through the points P and Q. So it can be some, let's say the PQ goes through the point somewhere like this. Okay, so it means that the normal vector for plane 1, let's say this is our plane 1. This one is parallel to and to plane 2, and also our PQ can be something like this, where PQ is also parallel to this plane 2. Okay, now from here we can find the equation of the plane, where first we identify what is the normal vector. The normal vector for plane 1 is given as 3, 2, minus 1. And our PQ can be obtained by calculating the vector of OQ minus OP. So our OQ will be -1, 3, 2 minus OP, which is 1, 2, and 4. So -2, 1, minus 2. So now we have two vectors. So from here we can find another vector that is orthogonal to pi 2 using these two vectors. Okay. By using the cross product of n1 cross pq, so we will have the vector of n2 equals to n2. So n1 will be 3, 2, minus 1, and our PQ will be -2, 1, negative. Where this will be equals to 2 minus 1. So find the determinant of I minus J. And then for K, so this will be -4 plus 1, -3I. And then this will be plus 8J. And then 3 plus 4 will be plus 7K. So now we have the vector K, and then since it goes through the points, so we have the points here, P and Q. So we can just use this point to obtain the equation of the plane, where the equation of the plane will be AX plus BY plus CZ equals to AX naught plus BY naught plus CZ naught. So our ABC is this value, and we can use the point P, where point P is 1, 2, and 4. We know this is the vector. So we can use this point 1, 2, and 4. So X naught, Y naught, Z naught. So just substitute into this equation. Plus 8Y plus 7Z equals to which is equals to 41. So our equation of plane will be negative 3x plus 8y plus 7z equals to 41. Is it okay? You understand now? Alright. So, any other questions? Alright. So if you have no questions, then okay lah. That's all for today. Doctor, what if my operations are in total opposite? So you means that you get 3x minus 8y minus 7z equals to negative 41. Still it's correct. As long as the value is the same. Because you can bring this to the right side and this one can bring to the left side. Alright. Yeah, it will not change the answer. Except if you get 3x minus 8y minus 7z equals to 41, then something wrong with your sign. Okay, it should be 3x minus 8y minus 7z equals to negative 41. Yeah. Okay. Okay, if there is no more questions, then we can end our live meeting. So thank you everyone for your cooperations. Hold on, I want to give you the attendance form. So please fill in the attendance form for today. So this will be my last class with all of you. Next week, Dr. Azhar will take over the class. Okay? So thank you everyone. If you have any questions, you can just ask in the WhatsApp group. Alright. Assalamualaikum.